Hi, good morning students. In the last class we already discussed about a very small theorem related to Pythagoras theorem. So today we are going to discussing about another very important theorem, and this theorem is very important for your examination also. So that is Pythagoras theorem. So we know that Pythagoras theorem is related to right angle triangles only, right? So we already know about that in earlier classes like 8th standard or 9th also. So now we are going to derive that theorem. You just observe carefully and understand the exact proof of this theorem. So each and every step is very important in this particular theorem. So you just observe carefully. So first of all, we moving on Pythagoras theorem. So in this particular theorem, we have one statement. You should remember or you should understand the statement first before going to prove this particular theorem. So then what is that statement? So you already know about that statement, or you are having some idea about that statement. So the statement is, so first of all you just write down the statement here. So the statement is, in a right triangle, square of the hypotenuse is equal to the sum of the square of the corresponding sides. So this is the statement for Pythagoras theorem. So you just observe the statement carefully. In a right triangle means a right angled triangle. So we already know about the definition or meaning of right angle triangle. And square of the hypotenuse is equal to the sum of the square of the other two sides. So its meaning is, if you just consider any right angle triangle, so here you just observe the diagram here. Consider ABC is a right angled triangle, right? So you just observe that figure. So you notice that yes, of course, ABC is a triangle, particularly it is a right angled triangle. So after considering that right angle triangle, we notice that a very important angle, that angle is angle B, that is a right angle. Right angle which measures 90 degree. If a triangle having right angle, so that is called it as right angle triangle, right? So by considering this right angle triangle, we already know about the sides, naming of the sides of right angle triangle. So these two sides are called it as legs or arms of a right angle triangle, but very important side, that is AC, it is called it as hypotenuse or longest side of a right angle triangle. Why it is called it as, or what is the exact definition of hypotenuse? So you just observe here, side opposite to the right angle in a right angle triangle is called it as hypotenuse of a right angle triangle. So this is the meaning of hypotenuse. So and then you just observe, or you can measure each and every sides in a right angle triangle, which shows us hypotenuse is the largest side in any right angled triangle. So this is the meaning of hypotenuse. Now don't wasting of our time, we moving on theorem here. So in this particular figure or triangle, square of the hypotenuse. Then now tell me, what is the hypotenuse here? AC is the hypotenuse. So then square of the hypotenuse means, so you just apply the statement to this particular figure, that's it. So square of the hypotenuse means, we know that AC is the hypotenuse, so then square of the hypotenuse means AC square, right? square of the hypotenuse is equal to the, so is equal means we should mark like this, equal symbol is equal to the, so AC square is equal to, or square of the hypotenuse is equal to sum of the square of the, sorry, other two sides, that is not corresponding sides, other two sides, other two sides. So that is not corresponding sides. So square of the other two sides. What are the other two sides here? So those two sides are AB and BC. So you should apply the square on both the sides and then make it sum. So those two, the sum of those two sides, square of their sides is equal to the square of the hypotenuse, which gives an idea about AB square plus BC square, right? So this is the condition we are going to derive in this particular theorem. So this is called it as a Pythagoras theorem. So the statement is very easy. ಸೊ ಇಲ್ಲಿ ನೀವು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನ ನೋಡಬಹುದು. ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲೇ ನಿಮಗೆ ಓವರಾಲ್ ಥೀಮ್ ಅರ್ಥ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಹೈಪೋಟೆನಸ್ ಅಂದ್ರೆ ಹೈಪೋಟೆನಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತು, ಅದನ್ನು ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕು. ಈಸ್ ಈಕ್ವಲ್ ಟು ದ, ಅದು ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಸಮ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್ ಆಫ್ ದ ಅದರ್ ಟು ಸೈಡ್ಸ್. ಈ ಹೈಪೋಟೆನಸ್ ಅದರ್ ದೇನ್ ಹೈಪೋಟೆನಸ್ ಅನ್ನ ಬಿಟ್ಬಿಟ್ಟು ಇನ್ನು ಎರಡು ಸೈಡ್ ಉಳಿತಾವಲ್ಲ, ಆ ಎರಡೂ ಸೈಡನ್ನ ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಸಮ್ ಬರುತ್ತೋ ಆ ಸಮ್ಮಿಗೆ ಆ ಹೈಪೋಟೆನಸ್ನ ಸ್ಕ್ವೇರು ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. So we are going to prove this condition in this particular theorem. So this is the exact meaning of this theorem. So now we moving on data section here. So here data, the given data, that is, so the given information is they are given a right angled triangle. That's why you just write down in right angle triangle ABC, and then ನಮಗೆ ಮತ್ತೆ ಇನ್ನೇನು ಗೊತ್ತು. ಸೊ ಅನದರ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಇಸ್ ದೇರ್, ದಟ್ ಈಸ್ ಎ ರೈಟ್ ಆ್ಯಂಗಲ್ ಅಟ್ ಆ್ಯಂಗಲ್ ಬಿ. ದಟ್ಸ್ ವೈ ಸೊ ಆ್ಯಂಗಲ್ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 90 ಡಿಗ್ರಿ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಗಿವನ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ರೈಟ್? ಸೊ ನೌ ವಿ ಮೂವಿಂಗ್ ಆನ್ ಟು ಪ್ರೂವ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೂವ್ ಹಿಯರ್. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೂವ್ particularly that statement, that is AC square is equal to AB square plus BC square, or it can be taken as AB square plus BC square is equal to AC square. Both are same. AC square is equal, you can interchange LHS and RHS, so both are same. AC square is equal to AB square plus BC square andrunu onde, AB square plus BC square is equal to AC square andrunu onde. So don't confuse about that two different kind of statements. So then we moving on next part, that is very important part, that is construction part. This is also very important part in each and every theorem. So you just observe here the construction of this theorem is, you just draw a perpendicular or draw BM, or you may take down as BD perpendicular on AC. So you just draw a single line, so which is perpendicular to the hypotenuse of the right angle triangle. So here, so this is perpendicular, so D, point D, because we already know the statement of previous theorem. If you draw a perpendicular from the right angled vertex of a right angle triangle to the hypotenuse of a right angle triangle, then that perpendicular line divides it into two right angle triangles. So then those two parts are similar to the original triangle. So this is the statement of previous theorem. So that's why we should construct a perpendicular in the given triangle. So now we have two triangles, those are all ADB and BDC, and one more right angle triangle is there, that is the original triangle, that is ABC. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಈ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡೋದ್ರ ಮೂಲಕ ನಮಗೆ 3 ಟ್ರಯಾಂಗಲ್ ಸಿಕ್ತು. ಏನಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡಿದ್ವಿ ಅಂದರೆ, ಪ್ರೀವಿಯಸ್ ಥಿಯರಮ್ ಅಲ್ಲಿ ನಾವು ನೋಡಿದ್ದೀವಿ, ಯಾವುದೇ ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ಗೆ ರೈಟ್ ಆಂಗಲ್ಡ್ ವರ್ಟೆಕ್ಸ್ ಇಂದ ಹೈಪೋಟಿನಸ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಅದು ಅನದರ್ 2 ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಆಗಿ ಸಪರೇಟ್ ಆಗುತ್ತೆ. ಆ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ನ್ಯೂ ಟ್ರಯಾಂಗಲ್ ಒರಿಜಿನಲ್ ಟ್ರಯಾಂಗಲ್ಗೆ ಏನಾಗಿರುತ್ತೆ, ಸಿಮಿಲರ್ ಟ್ರಯಾಂಗಲ್ ಆಗಿರುತ್ತೆ, ಆರ್ ಸಿಮಿಲರ್ ಟು ಈಚ್ ಅದರ್ ಆಗಿರುತ್ತೆ. ದಟ್ಸ್ ವೈ ವಿ ಶುಡ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಎ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಸೊ ನಾವು the very important thing is, that is also very easy. Before going to the proof of this theorem, I would like to give you an idea about the proof. So illikondu idea enappa andre very simple, you just compare two triangles twice. What are those triangles? ನೀವು ಎರಡು ಟ್ರಯಾಂಗಲ್ನ ಒಂದೊಂದ್ಸಲ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಬರಬೇಕು. ಸೊ ದೋಸ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಆರ್, ಒನ್ ಈಸ್ ADB, you just compare triangle ADB with original triangle ABC, and in this particular step you got one condition, and then you can compare BDC and ABC. So now then add those two equations, then you will get the proof of this theorem. That is a simple trick or simple method or simple hint to remember how to prove this particular theorem, right? So now we moving on the proof of this theorem. So I already told you, consider right angle triangle. What about first one? ABC and right angle triangle ADB, right? So you should show both the triangles are similar. So how can you show these two triangles are similar? Yes, of course, we know that in triangle ABC, angle ABC which is equal to angle ADB, because these two are right angle triangles as well as these two are right angles. And one more angle is there, because we should apply AA criteria for proving these two are similar. So one more angle is that is A is common angle of both the triangle ADB as well as ABC. ಹೌದಾ? ADB triangle ಅಲ್ಲೂ ಕೂಡ angle A ಇದೆ, ABC triangle ಅಲ್ಲೂ ಕೂಡ angle A ಇದೆ. That's why we should take down that angle also. So that angle is angle BAC is equal to angle DAB. These two are common angle. So CA, which indicates common angle. So therefore right angle triangle ABC is similar to right angle triangle ADB. So now we have these two triangles are similar because of AA similarity criterion. So this indicates AA, angle similarity criterion. So after proving these two are similar, we can easily write down in two pairs of ratios here. Those two pairs are, ಇಲ್ಲೂ ಕೂಡ ಅಷ್ಟೇ ಒಂದು ಹಿಂಟ್ ಇದೆ. ಸೊ ನೀವು ಪೇರ್ ಹೆಂಗೆ ಬೇಕಂಗೆ ತಗೊಳಕ್ ಬರಲ್ಲ. 3 pairs ಪಾಸಿಬಲ್ ಇದಾವೆ ಇಲ್ಲಿ, ಬಟ್ ನೀವು ತಗೋಬೇಕಾಗಿರೋದು 2 pairs. ಆ 2 pairs ಯಾವ ರೀತಿ ತಗೋಬೇಕು ಅಂದರೆ, ಯು ಶುಡ್ ಟೇಕ್ ಡೌನ್ ಫಸ್ಟ್ 2 and here also first 2 and then first last. So this is the hint of this theorem. So then in second comparison, you just take down second 2 and second 2, then first and last. That's it. You should keep it in your mind. So AB divided by AD is equal to AC divided by here AB. This is equation number 1, right? So after proving equation number 1, we moving on second one by consider, you just write down this part after this one. So consider second pair, that is ABC, right angle triangle ABC and right angle triangle BDC. You should consider ABC and BDC. So now we have we should prove these two triangles are similar also. Illu kuda similar anta prove ಮಾಡಬೇಕು. That's why we use AA similarity criterion. You should keep it in your mind. That is also very important. Angle ABC which is equal to angle BDC, because these two are right angles. And then one more angle is there, that is angle C is the common angle of both the triangle. One is BDC and as well as another one is ABC. That's why we can define like this: ACB is equal to BCD. Both are common angles. So after observing these two angles, we conclude that right angle triangle ABC similar to right angle triangle BDC. Right angle triangle ABC is similar to right angle triangle BDC. Now you should write down another pair of ratios. Those ratios are second second 2 and then first last. You just apply that method. We conclude that BC divided by DC is equal to, one more is there, that is AC divided by BC. So now, in this step, you may take off for equation number 1. You just cross multiply each other. We get AB into AB. This implies AB into AB, AB square is equal to AC into AD. You just write down AC dot AD. Consider this as equation number 1. This is very easy. You just cross multiply the given ratios. You will get AB square is equal to AC dot, that means into AD. So here also you just follow the same method. BC into BC, BC square, which is equal to AC into DC. So consider this as equation number 2. Now we get two equations. You just add both the equations. Why we are going to add these two equations? By observing the proof of this theorem, we have AB square plus BC square. Here AB square is the LHS of first condition and BC square is the LHS of second condition. That's why you should add both the conditions. Now we get, add 1 and 2, we get AB square. You just add LHS with the second LHS plus BC square is equal to, you just add the RHS with second RHS. AC dot AD plus AC dot DC. Right? You just observe. Don't confuse about that one. So now write down AB square plus BC square as it is, which is equal to, you just take down AC as common factor. Now we get AC into AD plus DC. AD plus DC. You just observe here, AD plus DC, iveradunu add madidre ಏನು ಸಿಗುತ್ತೆ AC. So that's why in place of AB square plus BC square is equal to, in place of AD plus DC, we can easily take down AC itself, because we in the figure AD plus DC, which is equal to AC. So now therefore AB square plus BC square, which is equal to AC into AC, which is equal to AC square. So now we get a proof of this theorem, that is square of the hypotenuse of a right angle triangle is equal to the sum of the square of the other two sides. So this is the proof of this theorem. You just observe carefully. So this is very important theorem and exam oriented theorem also. So this is the easiest proof of this theorem. You just remember the hints I am already given in this particular theorem. So you should keep it in your mind and don't forget the proof of this theorem. So this is the easiest proof of Pythagoras theorem. So this is very important theorem. I hope you all understand the proof of this theorem. So that's it for today's class. We will meet you in the next class. Thank you.